Hi there. Welcome to the part 2 of module 2 for this Cisco CCNA3 class that we are having. In this part, we are going to be looking at, or we'll continue from where we stopped. And if for any reason you missed out the parts, then you can go back to my channel and you can watch part 1. Remember to subscribe and click like so that you will have knowledge of more videos that I upload. We are going to take multi-access OSPF network. Multi-access OSPF network. All right, so another type of network that uses OSPF is the multi-access OSPF network. From the word multi-access means multiple access, okay? We have talked about point-to-point, where you are talking about two devices or two routers having an OSPF handshake. Now we're looking at multi-access, where you have multiple devices connecting in a particular way. So the multi-access OSPF networks are unique in that one router controls the distribution of link states advertisements. Generally, the router that is elected for this role should be determined by the network administrator, maybe through the proper configuration of the way it's going to be. So you see the difference in this case, you have a switch, or rather a broadcast device, okay? You have a switch, which is a broadcast device, and then you have different devices, different routers connecting to this particular switch. So based on that topology, we are going to look. So in multi-access networks, OSPF elects a DR, which is our designated router, and the BDR, which is the backup designated route. The DR is responsible for collecting and distributing link state advertisements, or LSAs, sent and received. So the DR uses the multicast IP version 4 address of 224.0.0.5, which is meant for all OSPF routers. So a BDR also elected in the case the DR fails. The BDR listens passively, okay, and maintains a relationship with all the routers. So if for any reasons the DR stops producing hello packets, the BDR promotes itself automatically and assumes all the roles that the DR performs. All other resources becomes a drawder, okay? A router that neither is a DR or a BDR is called a drawder, all right? So drawders use multi-access address of 224.0.0.6 and send OSPF packets to the DR and the BDR. So all drawders relate to the DR and the BDR. It is the BDR and the DR that are going to now relate to the other devices. So in a multi-access topology, as we can see in this particular image, remember in part 1, there are 3 routers, 1, 2, and 3, okay? Now, these 3 routers are interconnected over a common Ethernet multi-access network, which is this guy here. So because the routers are connected over this multi-access network, OSPF has automatically elected DR and BDR. So router 3, which is this guy here, has been elected as the DR, okay? And remember, we talked earlier that one of the process in election is the value in the process ID. all right, and the router ID, sorry. So, so the DR is selected because its router ID is 3.3.3.3, which is the highest. You see, router 2 is 2.2.2, router 1 is 1.1.1. So router 3 is now the designated router. Router 2 is the backup designated router because it is the next in the hierarchy. Okay. So to verify the roles of the OSPF version 2 routers, you can use the show IP OSPF Internet Gigabit Ethernet command. All right. So if you run this command on the interface, it's going to tell you that it is either a DRODA or a DR or a BDR. Okay, so it tells us that it's a DRODA with a priority of 1, and it will tell us that the designated router is what? 3.3.3.3, which is router 3. All right, and you tell us the backup designated router, which is BDR, is router 2. All right, now it will tell us that it has neighbor adjacencies to both of them. Okay, so if I come to router 2, I'm in router 2 now, and I run the same command, show IP OSPF Internet interface Gigabit Ethernet this. It tells me that this router is the BDR, okay? And it will tell me that the DR is router 3 with this ID. And router 2, which is itself, is with this. And it'll tell me it has neighbor adjacencies with router 1 and router 3. And router 3, it will specify that it is the designated router. Okay. Now, if I come to router 1, and I run the same command, what am I going to get? It will tell me router 1 is a DRODA, and it will point me to router 3 as the DR, router 2 as the BDR. So that's how to verify. So to verify the adjacencies, you use, like we said, the show IP OSPF neighbor command. All right, so the state of neighbors in multi-access networks are shown either full DRODA or full DR or full BDR. Okay, now if it is a full DRODA, it means that the DR, this is a DR or BDR route that is fully adjacent with a non-DR or non-BDR router. So these two neighbors can exchange hello packets, update queries, and reply. If the status is full DR, it means that the router is fully adjacent with the indicated designated neighbor, router neighbor. These two neighbors can exchange hello packets, update queries, replies, and acknowledgement. If it is a full BDR, it means that the router is fully adjacent with its indicated backup designated neighbor. So these two neighbors can exchange hello packets, update queries, replies, and acknowledgement. But if it is two-way DRODA, it means that the non-DR or non-BDR routers has an adjacent relationship with another non-DR or non-BDR. So these two routers exchange only what? Hello packets. So you see, but if it is related with either a DR or a BDR, it can send updates, queries, replies, and acknowledgements. All right, but if it is just within themselves, it can only do hello packets. So the normal state for an OSPF router is usually full. So if a router is stuck in another state, it is an indication that there are problems in forming adjacencies. So the only exceptions to this is the two-way state, which is normal in a multi-access network. The output generated here, as you can see, is the output for router 2, and it actually confirms this. So if I do show IP OSPF neighbor, it will tell me that I have neighborship with router 1.1.1, and the relationship is full drawdown. And it tells me I have a relationship with router 3, which is the DR, then I have full and then DR. So that is what it will show. Now, the default election process is that the routers in the network elect the router with the highest interface priority as the DR, okay, as the DR. And then the second interface priority becomes the BDR. So the priority ranges between 0 to 255, okay? Then if the interface priority value is set to 0, that interface cannot be elected as the DR nor the BDR. So, but the default priority value is 1, right? So, if you want to disqualify any router from participating in the election, just change the priority value. So if the interface priorities are equal, then routers with the highest router ID is elected as the DR. Okay, so if I want to rig the election now, and I want router 1 to be the DR, I just increase the priority value. So the router with the second highest router ID becomes the BDR. So if I can change the priority value above 1, I can change the router ID to be the highest. Then I can rig the election. So the election process takes place when the first router with the OSPF enabled interface is active on the network. So if all the routers on the network have not finished putting, it is possible that a router with a lower ID becomes the DR. So in addition, the new router does not initiate the election process. So after the DR is elected, it remains the DR until the DR fails, or the OSPF process on the DR fails or it stops, or the multi-access interface on the DR fails. So once it fails, the BDR automatically takes over. So if the interface priority are equal on all routers, the router with the highest router ID is then elected as the DR. So instead of relying on the router ID, it is better to control the election by setting interface priorities. This also allows router to be the DR on one network and a BDR or a drawdown in another network. So to set the priorities of an interface, you just use this value, IP OSPF, then the priority value. So it can be anything between 0 to 255. So once you set it to 0, it means that it is not going to participate in the election. But between 1 to 255, it can participate. So this is how you do interface. You enter the interface, then IP OSPF priority 255. This is an example that shows that router 1 priority has been set to the highest. Okay, so once you do that, then you say clear IP OSPF process. You say yes, then it's going to now perform its adjacencies. Now we're going to have a packet tracer activity now, and in the activity, we are going to examine the designated router and the BDR roles and watch the roles change when there is a change in the network. All right. Then we're also going to modify the priority to control the roles and force a new election. All right. Then we're also going to verify routers filling the desired rows. Okay, so that's what we're going to do now. Okay, so this is the topology we are going to be working on, and we have an activity that we are going to be looking at. So we are going to examine the DR, BDR in this activity. Then we will modify OSPF priorities and force selection. So this is what we'll do in part 1. We'll examine this. So we'll follow it bit by bit. Okay. All right. So this is what we are going to do the verification. Right. So first things first, we'll go to this router A. Let's start with step 1. Okay. It says, when you first open the packet tracer, you may notice that the lights are amber, which is true. All right, I think we're done with that. Verify OSPF neighbor states. So use the appropriate commands on each router to determine the current DR and BDR. If a router shows Troda, it means the router is not a DR or BDR. So let's go to this router A and then do show IP OSPF neighbor. So, okay. Come in. Put this like this. All right, so let's go to router A here. Okay, so show IP OSPF neighbor. I need to enable first, then show IP OSPF neighbor. Very good. So once I do that, let me expand it so that we can see it better. Okay. Right. So you see, it tells us the neighbor details that we have here. And based on the neighbor details that we have, this is what it showed us here. Once we do that command, this is what it's showing us. Okay, it will tell us that the priority value, this is full DR and then BDR and things like that. So let me get back to it. Sorry. Okay, so the next thing I'm going to do, what is the instructions saying in the activity? Right, show IP OSPF neighbor. Okay, that's what we did for router A. So we're going to do for router B. So here we take note of this, then take note of this. Okay, so let me go to router B. Where's router B? This is RB, right? Good. So this is RB. All right. So RB. Okay. Okay. So I do the same. Sorry. Show IP OSPF neighbor. Very good. So you see, for router B, we have to priority 2. We have this is full DR. Okay, designated router. This is designated router, full DR. And then this is the designated router here, which is router 3. Okay, and then it is also related, it has a synchrony with router 2. So let's go to router C now and find out. This is, where's router C? Router A, router B. I guess this is router C. Command line interface. Okay. Then we say what now? Okay, use the same command, show IP OSPF enable. Right, so in router C, okay, you see priority 1 here, priority 1 here. And then it's telling me this is full BDR. So router 2 is BDR. Router 3 is a drawdown. Okay. So if you see router A, this is router A. On router A, you see router A has a synchrony with router 3 and router 2. And router 3 here is the full DR, that is the DR. When we come to router B, see on router B here, what did it tell us? It's telling us this is where is it? See router 3 here. So if we come to the question, they're asking us here, which router is the BDR? Let's see. There's the question, which router is the DR, which is the BDR? So our DR is router what? 3. Our BDR is router 2. So what is the OSPF state for router A? So where's router A? This is router A. What is the state? The state is full. Is that not so? All right. So then they say we should turn where is it? Let me minimize this. Okay, it says turn on IP OSPF adjacency debugging. You can monitor the DR and BDR election process with a debug command on the router A and router B. So we enter the following command. So on router A and router B, we're supposed to enter this command. Okay, debug IP OSPF adjacency for router A, debug IP OSPF for router B. Okay, so where's router A and B? This is router B. Debug IP OSPF adjacency. Okay, so debugging is on. So I go to router A and do likewise. Router A, sorry, debug IP OSPF adjacency. Okay, it's on. So what is now the next instruction? Step 4 says disable the Gigabit Ethernet on router C. To do that, use the shutdown command to disable the link between router C, and the switches will cause roles to change. So wait for 30 seconds for the dead timers to expire on router A and router B. Then according to the debug output, which the router has, was elected DR, which router was elected BDR. Okay, so we're supposed to what? Go and shut down Ethernet, Gigabit Ethernet 0/0 on router C. So let's see the topology. This is router A, router B, router C, which is our DR. You remember DR. So we're supposed to enter this router C and shut down the we shut down the Gigabit Ethernet 0/0 interface. So this is router C. So first of all, let's do show IP interface brief. It will give us an idea. So on this router, it has how many interfaces? 1, 2, 3 interfaces. All right, apart from the VLAN interface. So this is the interface we're supposed to shut down. Gigabit Ethernet 0/0. So you see, it's up, it's up. All right, so we're supposed to go into this interface and shut down. So I go config terminal, then interface Gigabit Ethernet 0/0. Then I say shut down. Very good. So I have shut down. The moment I shut down, it tells us the link is down. Okay, and look at it here. There are some adjacency messages that took place. Now let us check, what do we call it now? Router A and router C. Let's see the instructions for us. They said wait for 30 seconds for the dead timers to expire. Okay, so let's wait for some few seconds. Let's see. Okay, so I think the 30 seconds should have expired by now. So we're going to now go back and do verify. Okay, we'll do show IP OSPF neighbor. We'll do that on router C, and then we will see what is there. Okay, so where is router C? It's router C. Exit. Show IP OSPF neighbor. Wow. Can we see anything? Can't see anything here. You see, it's gone. So let me go to router A here. Can you see the information that is going? Election process. Can you see? This is where it started. It's 30 seconds ago. The process is started. It informs us that the DR is down. Look at it, it's full to down. The adjacency is full to down. Then it says build router link state advertisement for area 0. So a broadcast is made. Then OSPF DR BDR election on Gigabit. This. What are they doing? They're saying we're electing this guy as BDR, and then we are electing, look at it, this guy as the DR. That's what they are electing. So this is DR, this is BDR. Election has been done and is complete. Okay. Wow. So see the process. Their INEC seem to be working well. All right. So this is cool. Can you see that? This is cool. So let's check on router B and see what is going on there. You see, this is router B. Router B is having the same issue, the same information. You see, I'm in router B now. The same election process. Wow. This is awesome. Cool. All right. So let's go back to the instructions. So they say we should restore the gigabit Ethernet on router C and re-enable the link between router C and the switch. Okay. So we wait for the DR election to occur. All right. So let's go to router C. Where is router C? Okay. This is router C. So let's go config T and then interface gigabit Ethernet 0/0. Sorry. 0. So no shutdown. All right. So the interface is now up. Now we're going to wait for 30 seconds. Then we'll now see the election process that is going to take place. Okay. Let's see. Hope our debugging is on. Debug. Okay. Our debugging is on. So, all right. So can you see it has started again? Election has started on this, and they're electing this guy. They're electing this guy. Somebody is saying, I move for the election of this. And can you see? Process is ongoing. They don't waste time more. Election and election results is out within a very, very short time. Wow. So you see, basically, this is how it works. All right. Okay, so let's go back to our session. So we are done with this now. So let's proceed. Okay, now modify single area OSPF. Version 2. Cisco OSPF cost metric. So routing protocols use a metric to determine the best path of a packet across the network. So OSPF uses cost as a metric. So a lower cost indicates a path. The Cisco cost of an interface is inversely proportional to the bandwidth of the interface. So therefore, the higher the bandwidth indicates a lower cost. So the formula that is used to calculate the cost of the route is the bandwidth divided by interface bandwidth, sorry, reference bandwidth over interface bandwidth. So the default reference bandwidth is this. So the formula is in bits per second. All right, so bits per second. So this is 100,000 bits per second, which means is what now? 100,000 kilobits per second. This is 100 million, sorry, 100 million bits per second. So that means is 100,000 kilobits per second, which is 1 gig. All right, so because, sorry, 1 gig, yeah. So because OSPF cost value must be higher, must be an integer, sorry, fast Ethernet, which is 100 Mbps, gigabit Ethernet, which is 1,000 Mbps, 1 gig, and then 10 gigabit Ethernet, which is 10 gig, share the same costs. So to correct this situation, you can adjust the reference bandwidth with the auto cost reference bandwidth command on each OSPF router. So you can manually set the OSPF cost value with the IP OSPF cost command. All right, so this is the table that shows the breakdown, the calculations for normal Ethernet 10 Mbps, for fast Ethernet of 100 Mbps, and for gigabit Ethernet 1 gig and then for 10 gig. So if you observe, the higher the bandwidth, the lower cost. So the lower the cost, the more preferred the route. Okay, the lower the cost, the more preferred the route. So you see, Ethernet 10 Mbps has a cost of 1. 100 Mbps has a cost of 1. Gigabit Ethernet has the cost of 0.1 or 1. So we say it's the same cost due to reference bandwidth. All right, so the cost value must be an integer, and if something less than an integer is calculated, the OSPF actually rounds it up to an integer. So for this reason, all interface faster than fast Ethernet will have the same cost value of 1. So to assist OSPF in making the correct path determination, the reference bandwidth must be changed to a higher value to accommodate network with links faster than 100 Mbps. So changing the reference bandwidth does not actually affect the bandwidth capacity on the link. Rather, it simply affects the calculation used to determine the metrics. So to adjust the reference bandwidth, we use the command AutoCost reference bandwidth. All right, and you give the value in Mbps. All right. So if I do the adjustment, what it simply means is that the Ethernet is going to have 1,000. The fast Ethernet is going to have a cost of 100. The Gigabit Ethernet is going to have a cost of 10. And the 10 Gigabit Ethernet is going to have a cost of 1. So you remember, the lower the cost, the more preferred the route. Okay, so you use the show IP OSPF command to verify the cost configuration. So the cost of an OSPF route is the accumulated value from one router to the destination network. So assuming the AutoCost reference bandwidth of 10,000 command has been configured on all 3 routers, the cost of the link between each of the router is going to be like 10. You see, the cost will be each one like 10. All right. The loopback interface is going to have the cost of 1. All right. So that's if we use the AutoCost reference of 10,000. All right. So, and this is how to calculate. You can verify it using the show IP route command. So if I do show IP route and then I pipe and I say include, then I put in the path that I want to calculate. I want to put the destination network. All right. Then it's going to now show me, show IP route this, for instance, and you tell me the metric is 11. All right, so it will give you a metric. But you can manually set the cost value. The reasons to set the cost value is sometimes the administrator wants to influence the path. You want to force your traffic to follow a particular path. So causing different paths to be selected when what normally would have given a default cost and cost accumulation. So to change the cost value reported by the local OSPF router to the local OSPF router, you use the IP OSPF, then the cost value. All right. So if I do IP OSPF cost, then I'll put in the value that I want. All right, so that way I am manually adjusting it. So when you check your routing table, you will see this is the administrative distance of OSPF, administrative distance. That's the trustworthiness of the route. And then you will see the cost value that is being assigned to any of the destinations. Right. So hello packet intervals. The OSPF hello packets are transmitted to multicast address of 224.0.0.5. All right, so this is the default timer value on multi-access multi-point. So the default timer is 10 seconds. So the dead interval is the period that the router waits to receive the hello packet before declining the neighbor down or declaring neighbor down. So the dead interval expires before the routers receives hello packet. OSPF will then remove that neighbor from the link state database. So the router then floods the link state database with information about the down neighbor route, right? So Cisco uses the default of 4 times the hello intervals. So if you're using 10 seconds for the hello intervals, your 10 seconds will be multiplied by 4, all right? It will give you 40 to give you as the dead time. Now, how do you verify? If you do show IP OSPF interface, you're going to see the timer intervals as hello 10, dead 40. All right, so that's what it's going to show you. Another way to verify the same information, you can do show IP OSPF neighbor. It will tell you for router 3, I'm on router 1 now. So on router 3, it will tell you it has this value as the remaining for dead interval. And then for router 2, it will give you this. Okay. So how then do you modify these intervals? Modification has to do with changing the content or changing the value. You don't want it to be 10 seconds, you want to increase it or reduce it. So you use the command, you go to the interface mode. All right, so on that interface mode, then you use the command IP OSPF, then hello interval, then you put the value in seconds. Then IP OSPF dead interval, then you put the value in seconds. All right, so look at it. This is an example. I am on router 1, so I enter interface G000, and then I do IP OSPF hello interval, and I put the value as 5. Then dead interval 5 times 4 is what? 20. So I put it as 20. All right. So okay. So we have a packet tracer activity to do that. So we are going to now adjust the reference bandwidth account, and then we will now modify the OSPF cost values. Then we'll modify the OSPF hello times. All right, so when we verify the modifications are accurately reflected in the routes. Okay, so let's go into it. Okay, so this is the topology we're going to be working with. Okay, we have router 1, router 2, and router 3. And in the activity, we are supposed to be, let me see, what's our activity? All right, this is our activity. We're supposed to modify the OSPF default settings, and then we're going to verify connectivity. That is what we're going to be doing. So this is the instruction. First thing is we should test connectivity between all devices. So before modifying the OSPF settings, verify that all PC can ping the web server and each other. So if you come up here, they've given us the details. of what we are supposed to be pinging. Okay, is the addressing table. Okay. All right. Coming. Let me just put this one here. Is the addressing table, and the addressing table we have router 1, router 2, router 3, then PC1, PC2, PC3, then we have the web server. Then we have the various IP addresses, the interfaces, IP version 4 address, subnet mask, or gateway. So we're going to be using this to ping to verify our connectivities. Okay. So our instruction number 1 says tests connectivity. All right, test connectivity. So I will enter router 1. Okay, and make sure, or rather from one PC to the other. Before modifying, let's see what did the instructions say. Verify all PCs can ping the web server and each other. Okay, so let's begin. Let's begin with PC1. This is PC1. I will go to its command prompt. Go to its command prompt. All right, PC1 should be able to ping PC2. PC1, just type PC2. What is the IP for PC2? Look at it. PC2 is 172.161.2. PC3, no, PC2 is 172.162.2. PC3 is 192.168.1.2. So let's ping it and see. 172.16.2.2. Okay, the first one should fail, then the others should proceed. Very good. So the first one usually times out. So if I do now, it should all go well. All right, so you're good. So it can reach PC2. How about PC3? PC3 is 192.168.1.2, right? 1.2. Okay, so first should fail, timeout, the other should go through. Correct. So we are good in that. Then the web server is 64.100.1.2. Got it, 64.100.1.2. So 64.100.1.2. Okay, so you can see that we can reach all the pieces. We can equally go to any of the PC. Let's see, we've done PC1. We can go to PC2 and run the same test. We'll ping PC1, PC3. PC1 is 172.16.1.2. Okay, so let's ping PC3 192.168.1.2. Okay, then we can check the web server 64.100.1.2. Good. So that part of the instruction, I think we are done with it. So what is the next thing to do? Let's see. Say, so we've done step 1. Step 2, they said adjust the hello and dead intervals between router 1 and router 2. So we're supposed to enter the following commands. On router 1, we'll go to the interface serial 00, then IP OSPF hello interval 15, then dead interval 60. All right. So after that, after a short period of time, the OSPF connection with router 2 in the other router should show us this particular output. Okay, so we'll enter router 1 and make the changes. Where's router 1? It's router 1. Okay. Make it wider. All right, so enable, configure terminal, interface serial 0/0/0, then IP, well, it's IP OSPF hello interval was set to 15, then IP OSPF dead interval 60. Right, so we're supposed to go to router 2 and see what happens. So where's router 2? Okay. So router 2, this is what happens in router 2. Okay, so you see, it's giving us the adjacency process for this. So both sides of the connection need to have the same timer in order for the adjacencies to be maintained. All right, so what we're supposed to now do is to identify in router 2 the interface that is connected to router 1. Then we will now adjust the timer interface. All right, because the dead timer expired. All right, so in router 2, which interface is connected to router 1? This is router 2. Okay, so which interface is the 172.163.0? Let's see, 172. Sorry, missed it. If I come here, sorry, serial 0, serial 000, right? Can you see? Serial 000. Aha, it's 172.163.0. So it's serial 000. So we're supposed to go to serial 000 and now do the same thing. Okay. So router 2, enable, configure terminal, interface serial 000. Then we'll now do IP OSPF, the same command that we did earlier on. Hello interval 15, if you remember. Then IP OSPF dead interval, I think is 60. All right, so after a brief period, the adjacency would be full. All right, so can you see? The adjacency now is full and is connecting very well to that one. So I think we're good. All right, so having done that, let's see, what is the next thing to do? Step 3, adjust the bandwidth settings on router 1. Adjust the bandwidth settings on router 1. Then trace the path between PC1 and the web server located this. So notice the path from PC1 to the web server is routed through router 2. Okay, so OSPF prefers a lower cost path. So we're going to use this traceat command, this one. All right, we'll use that on PC1. And then we will see the traceroute will give us the path in which the router is taking its route. So you could see here, this is the output. So let's see our own. So let me go PC1. Okay. Where's PC1? All right, so PC1, I go to command terminal. Let's see how we can make it bolder for you. All right, so we're on trace search. Then the web server is 64. If you remember the IP, .100.1.2. Good. All right, so from what it is showing us here, showing us that the traffic leaves the PC and goes to this router, and then goes to this router, and then comes here. So which router is 172.163.2? It's for us to find out. Let's see based on the documentation we were given. Based on the documentation we're given, look at it here. Router, look at it. Router 2 is 172.163.2. Can you see? This is router 2. Okay. 3.2. Can you see it? Router 2. All right. So that is it. So what then is the instruction? Step 3. We got it 3.2. It says on router 1 serial this. Okay, set the bandwidth to 64 Kbps. This does not change in the actual port speed. So we're going to change the bandwidth here on serial interface. So I will just go to router 1, then I will do bandwidth command. Look at it here. This is the command. I'll use bandwidth and 64. So I'll do that in router 1. Okay, so where's router 1? This is router 1. Router 1. So, okay, so I'll go to interface serial 0/0/0 bandwidth, then I will use what? 64. Good. So what else? What's the next thing to do? Bandwidth 64. Then we're supposed to trace the path from PC1 now. Okay. So we'll trace at 10.101.2 on PC1. So where's PC1? This is PC1. See, this is the trace that we did earlier. So we're just going to repeat it. Okay, so we'll now compare the values. So you see, we did, this is the result. This is the first trace that we did. All right, so this, it leaves the host machine, or the host router, and it goes through this router, which is router, I think router 2, if I'm not mistaken. But now look at it, it has changed course. And you see, changed course before coming here, then coming here, then coming here. So it has changed course. So let me see if I can do that in the simulation mode. Simulation mode. Let's see if we can do it here. Okay. So let me run the ping again. Like this. Press enter. So you see the packet goes. See the packet goes. This is how it moves. Okay. See. This is how it's moving. You see it? See it? All right, so it has changed route before it gets to the web server. Okay, so I think that we have made the explanation there. So we're good on that. So let's check our results. Assessment activity. All right, so we are done 100%. Okay. Then let's come back to our lectures. Okay, so this is what we have done. Okay, so let's go to default route propagation. To propagate default route, the edge router must be configured with the following. A default static route using the IP route. Okay, then IP route 0.0.0.0, then space 0.0.0.0. What it means is that IP route, any IP coming from anywhere with any subnet mask going to anywhere with subnet mask. So you should follow the next hop or exit interface command. Then it says the default information originate is what we use to propagate the default route. Okay, so for instance here, interface loopback 01, then IP address was given to it, no problem. Then we now come and say IP route. I'm doing an IP route. This is it, and then I'm saying forward the IP route to this particular interface. Then once I do that, then I say router OSPF10 default information originate. Okay, so that particular command helps to propagate this particular default route in question. So you can verify the default route settings when you do show IP route. You see, it will show you the one with S and asterisk. It tells you that's a default route. All right, any IP address with any subnet mask. All right, so this is on router 2. This is it. So because it has been propagated, if you go to router 1, look at it here. The default route has been learned and propagated by OSPF. You see this S here means that it's statically configured. It was statically configured. So notice the route source on route 1 is O*E2, signifying that it was learned using OSPF version 2. The asterisk implies that it's a good candidate for a default route. So that is it. Now, the E2 destination here identifies this is an external route. Okay, the meaning of E1 and E2 is beyond the scope of this module. All right, so let's do that in a packet tracer and see if we can propagate a default route and then verify its connectivity. So let's do that. Okay, so this is our packet tracer. This is the design we are going to be, the topology we are going to be working with, so that we'll just do the propagation. So let's see what the instruction requires. It says propagate a default route. So test connectivity to the web server from PC 1, 2, 3, attempt to ping the web server IP address of this. Were any of the pings successful? That is what we're going to find out, all right, whether it was successful. And well, hopefully, probably it should not. Anyway, we'll find out. What messages did you receive? It was issued, maybe unreachability or something, or timed out. So, and then we'll now examine. So we're from PC 1, 2, 3, we're to ping the web server. This is the IP address of the web server, 64.100.1.2. So I'm going to go to PC1. Where's PC1? Sorry, it's PC1. Desktop command. All right, so here we are. Let me make it bigger. All right, so ping 64, what's the IP address? 64.100.1.2. Ping 64.100.1.2. All right, so the message we're getting is destination host unreachable, right? Then if we go to PC2, we should have the same thing. PC2, we're pinging what? 64.100.1.2. 64.1.2. Unreachable. Now, why is it unreachable? We need to find out first, so that when we are solving it, we will not make so. You see, the web server is over the internet. This is the web server. This is the internet. And router 2 is supposed to have a default route. Default route to say, okay, if you're going to anywhere outside this your local network, follow this route. So we don't have a default route. Okay, so that's what we are about to fix now. So they say configure a default route on router 2. Configure, so we enter router 2, we'll now say IP route. If you're going to any destination with any subnet mask, follow this particular interface. Okay, so why particular serial 010? The reason is because serial 010 is the interface that, look at it here, that takes you out. All right, the interface that takes you out. So we will now enter router 2 and now create the default route. So on router 2, just a minute. Okay, so we're creating a default route. First on router 2. So where's router 2? Okay. So fix enable configure terminal IP route. So what did I miss? IP route, then 0.0.0.0 space 0.0.0.0 space serial 0/1/0. Okay, so default route without gateway is not a point-to-point interface and may impact performance. Okay, yes. I think this warning, the router will give us a warning like this. That is, if this interface is not a point-to-point. And yeah, I think so. It's not a point-to-point, and so it may involve. So we can ignore this warning because it is a point-to-point connection. So I think it's okay. So we ignore the warning. So the next thing we are supposed to do is we're supposed to now propagate this particular route. Propagation means that we want it to send it across all OSPF connected devices or routers. So I'll now go to router OSPF1. Then I will propagate it. To propagate it, you use the command default information originate. Press enter. So when you do default information originate, we press enter. So what it means, if we go to router 1 now, we should be able to see the default route. Okay, where's router 1? Where PC1 is going to be pinging from. So if we come here, router 1. Okay, so if we do show IP route, what do we expect to see? Let me widen this a little. Okay. All right. Aha, this is what I'm looking for. Can you see it? Can you see? So it has populated it. So obviously, if we ping from PC1 now, where is our PC1 pinging? All right, PC1 is here. Maybe we should do our ping now and see what we're going to get. The first result, we got destination host unreachable. Aha, we are getting reply now. So you see, we're getting reply. So it means that we have successfully propagated the default routes. And let's check our results. Check results. Where is it? Assessments. Let's see. Okay, so based on our results, 100, we are cool, so we're correct. All right, so having done that, then we will go back to our lecture. Right, so I think this is the last, second to the last, if I'm not mistaken, verify single area OSPF version 2. All right, so after configuring single OSPF area version 2, you'll need to verify configurations. And these are the commands to verify: show IP OSPF neighbor, show IP protocols, show IP OSPF, show IP OSPF interface. You can use the show IP OSPF neighbor command to verify, like we said. If you do this, you're going to get the result expected. Okay, so if I run show IP protocols, for instance, it will give me the OSPF and the ID, the router ID. It will give me the interfaces, that are on this particular area, and it will give me the gateway information. So I think this is all about verification. So I think this is another activity I want us to quickly look at in the verification. Okay, I think it's okay. This is the activity I want us to look at: single area OSPF configuration. So we want to implement single area in both point-to-point and multi-access. So let's look at it. Okay, so this is the topology I want us to look at. We have the headquarters, we have the data service, we have OSPF here, and this is the, I think this is the instructions. Okay, we're given all this and the background. So what we're supposed to do, this is the requirements they were supposed to do. It says use process ID 10 for OSPF activation on all routers. Activate OSPF using network statements, and then inverse mask, that is use a wildcard mask on routers in headquarters network. Activate OSPF by configuring the interface of the network device in the data service network where required. Then we're to configure router IDs on the multi-access network routers. On BC, we use 6666, BC2, 5555, BC3, 44444. Then we're supposed to configure OSPF so that routing updates are not sent to any network that they are not required. That is that passive interface. Configure BC1 as the highest OSPF so that it will now become the BDR. Configure a default route to the ISP cloud, then automatically distribute default route to all. Okay, so this is it. So how do we proceed? So we will now pick each router based on the topology and configure. So we'll pick each of the device and then we will do our configuration. So let's move on. All right, so I think we are going to be configuring how many devices? 6. I think 1, 2, 3, 4, 5, 6. All right, so let's proceed. We've been given the information we need here. We've been given, so I'm going to make use of it. Then we work it out. So let's start with P2P1, which is this guy. Let's start with this here. All right. So enable config T. Now, based on the topology, we're going to now see, where is it? This is, which interface is this? Serial 2. Let's start with here. Serial 0/1/1. Okay, if I put here, all right. So serial 0/1/1, serial 0/2/0. Okay, those are the two major interfaces that are serial. All right, so, and where else? Gigabit Ethernet 000 and 001 are all down. So 010 is up. All right, so let's see, let's proceed into it. So do IP OSPF. Okay, sorry, let's go to the interface first. Interface serial 0/1/1. Then IP OSPF costs. We're given the cost of 50. We're given the cost of 50. Then interface, the second interface serial 0/2/0. I think we're supposed to do IP OSPF hello interval of 20 as we're given, and a dead interval should be ×4. IP OSPF dead interval ×4 should be 80 then. Sorry, 80. Okay, if I'm not mistaken, that should be it for this. Okay, no. Let's see, what's the instruction saying? Okay, they gave us the OSPF router process ID of 10. So router OSPF 10. Okay, they say we should configure auto reference bandwidth, auto cost reference bandwidth, right? Let me see. Yeah. Okay, so auto cost reference bandwidth. What value did they say we should use? 10,000. 10,000. Okay. All right. Network 10.0.0.0. Wildcard mask 0.0.0.3, which is /30 because it's point to point. Area 0. Then the second network, because there are 3 networks connected to it. Let's see them. Look at it. 1, 2, 3. So we have done this /30. We will do this one now /30. Then we'll do this one also. Okay. So we have 10.0.0.8. Wildcard mask 0.0.0.3. Area 0. Oh, sorry, made a mistake. Network. Then the third one should be network 10.0.0.12 with wildcard of 0.0.0.3. Area 0. Okay, so let's save our work. Then I think this should be it for router 1, right? Let's see what our instructions were. Instructions. All right. Process ID of 10, we have done that. Activate OSPF. Okay, we'll do that. Okay, we'll do for the remaining other devices. Okay. All right. Okay. So let's go to our second device, which is P2P2. Where is it? Okay, here you are. Here you are. Okay. Okay. Enable config activate OSPF router, OSPF process ID 10. Okay, let's see. All right, here in router 2, you see there are 1, 2, 3, 4 networks. And then 1 and 2 are LAN related networks. Can you see? So we're supposed to do passive on this guy and this guy. Then we can now advertise this. Okay, so that's what we're going to do. I think then we'll now configure auto costs bandwidth. So I think that's what we're supposed to do on this guy. So let's go. What's okay? Passive interface, Gigabit Ethernet. What's the interface? 0/0/0. Then we're supposed to do for the other interface 001. If I'm not mistaken, I think that's it. Then go to costs, reference bandwidth of 10,000. Okay. Then we're supposed to advertise those networks. Network, let's start with the serial and 0.0, wildcard mask 0.0.3, area 0, 0. Then I do the next one. Uh-oh, what did I do? Okay. I do the next one. It's going to be 10.0.0.4. Should be 10.0.0.4. Area 0. Then let's go to the LAN networks. Network 192.168.1.0/24 will be 0.0.0.255. Area 0. I made a mistake. Area 0. Then the second LAN is network 192.168.2.0.0.0.255. Area 0. Okay. I think we should be done here. Anyway, when we're done, we'll check our results and see where we missed out. Then we'll do. So let's check. The next one is PC3. That's this guy. It has 1, 2, 3 networks. One of this network is this is a LAN network. Is to a serial. So we will do the same thing. Router process ID 10 OSPF. Then we'll do passive interface on this guy. Then auto cost for bandwidth. Then we'll now advertise 1, 2, 3 network. Okay. All right. So let's do it. Enable configure terminal. Router OSPF 10. Then passive interface Gigabit Ethernet 0/0/0. Then out to posts reference bandwidth 10,000. Oh, sorry, 10,000. Okay. Then network will now begin to form adjacencies. 10.0.0.4, 0.0.0.3, area 0. Okay. Yeah, area 0. Okay, can you see adjacency is full and done? Then network 10.0.0.8, 0.0.0.3, area 0. Okay. Aha. Adjacency, correct. Then last one is network 192.168.3.0. What's the subnet mask? You see this one is /28. So /28. The subnet mask should be 255.255.255.2 240, right? If I'm not mistaken, 240 or 248. No, okay, I think 240. So the wildcard mask for this guy should be 0.0.0. I think 15. Area 0. Guess so, yeah. All right, so let's see if I work. Okay, so what's the next one is to go to, let's come to this side. Let's pick this guy, BC1. BC1. What do we need to do here? It has 1, 2, 3 networks. This network is a LAN network. This is point-to-point. This, okay, serial LAN. So let's see. We're supposed to do. Okay, what was the instruction? Okay. 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 So I think we're supposed to do the hello intervals, dead intervals. What else? What else? Hello intervals, dead intervals. Priority. We're supposed to change the priority. Okay. And I think basically that is it. Okay. So let's go into it and see what we can do. sorry. Okay. Enable configure terminal. Then interface Gigabit Ethernet 0/0/0. Then IP OSPF priority 255, because we want it to be the, what do they call it now? DR. And then IP OSPF 10 area 0. Then I go to the next interface, serial 0, I guess 0/1/0. And then IP OSPF hello interval of 20. Then IP OSPF dead interval like we did of 80. IP OSPF 10 area 0. So now, good. So I've gotten full adjacency. That's what I'm waiting for. I can exit. Now, it's now for me to set the router ID. Router ID, like we said. What is it? Okay, let's OSPF10. Router ID. What is the router ID here? Let's be sure. Look at it, 6.6.6. Router ID would be 6.6.6.6. Receive interface. Serial 0/1/1. But the costs reference bandwidth, we said what, 10,000. Okay, now let's populate our default route, but let's configure the default route first. Let's exit here, IP default. Sorry, IP route. I'm mistaken. IP route 0.0.0.0 0.0.0.0 serial 0/1/1, and then default information, what am I missing? Information originates. What am I missing? Defaults, okay. Information defaults. Okay, I'm supposed to be in the router OSPF default information originates. Thank you. Almost missed it. All right. So we're good now. Right, very good. All right, so let's now go to the second. We've done this guy. We're doing a similar thing to this router, BC2. BC2, enable, configure, terminal, interface Gigabit Ethernet 0/0/0 IP OSPF10 area 0. Then I go to the next interface, Gigabit Ethernet 0/ what is it? Okay, 0/0/1. Okay, IP OSPF10 area 0. Then I can exit it. Then I now go to form the router ID. Good, I have this. So now router OSPF10. This is going to be BC2 is router ID should be 5.5.5.5. Passive interface Gigabit Ethernet 0/0. Okay. Then I can now do my bandwidth, auto cost reference bandwidth 10,000. Right? So see, done. See, done. Next thing is, I think the last one, which is BC3. BC3. Okay, can now do same thing there. I'll start by interface Gigabit Ethernet 0/0/0. And then IP OSPF10 area 0. Then I do for the next interface Gigabit Ethernet 0/0/1. IP OSPF10 area 0. Then I now form the router ID of, I think this should be 4.4 if I'm not mistaken. Yeah, 4.4. BC3. And router OSPF10 router ID would be 4.4.4.4. Then passive interface Gigabit Ethernet 0/0/0. Then I do my bandwidths, auto costs, reference bandwidth 10,000. Good. Save my work. Oh, sorry. All right. Okay. I mean, copy on start. Very good. So now let's check and see where we have gone wrong. Let's check our results. Check results. Oh, 103 over 103. 51, we've got it all right. So, wow, this one is a little bit difficult, but we've gotten it. All right. So, let's go back to our PowerPoints. Back to our class. Where's our PowerPoints? Okay. This is where we were. So, I think this is the lab that we have done. And thank you so much for watching. Please don't forget to subscribe and click like so that I can, when I upload next videos, you'll be notified. Thank you. Have a lovely day.